Hi, good morning, guys. I am Sarang. I am Vice President Marketing at Diamante Blockchain. We are a layer one blockchain company, and we have our own blockchain protocol, which is Diamante Net. And today, the workshop is taken up by Surya. So, he's our group technical lead, and Calvin Joshua, he is our blockchain lead. So, Surya, I think we can start the session.
Yes, thank you, Sarah, for nice introduction. Let me share my screen.
Sure.
Yes, I hope everyone can able to see my screen.
Yes. And also one more thing, guys. So after the workshop, we will be having a Q&A session as well. So please drop your queries in the chat box. So we will answer it one by one.
Yes. So hello everyone. So today we'll give some uh, later also we have given some idea about some Diamond Net hackathon and about our network Diamond Net. Today we'll give some practical workshop about our Diamond Net. So me first will give introduction of Diamond Net and later part Calvin will join and will give some practical workshop related things. Okay. So about today's agenda, first we'll discuss about what is Diamond Net and what are the consensus protocol using for Diamond Net, and we also discuss about different tracks and on the tracks how can you build some dApps and DeFi systems, DeFi tracks, gaming track and all the things. And also Kelvin will give you some hands-on experience how you can build your tracks, and last you can check how you can build your project and submit your project on our Diamond Hackathon. Okay, so first we'll start about, let's talk about our blockchain network that is called Diamante Net, which was established in 2018 and got forked from the Stellar blockchain. So where we started working more in depth and we can actually, with better engagement and better throughput scalability measures for our network. So on this, how Diamante Net came into existence. So from that inception until now, we have worked on various updates and security features. So it has now evolved into a fourth generation layer one blockchain. So as you know, the layer one blockchain is the base layer of a blockchain network that provides a fundamental infrastructure and a primary protocol for the entire ecosystem. So based on our layer one blockchain, so you can build different types of tracks like DeFi, gaming, and some real world assets tracks. So our Diamond Net gives a high throughput and security that processing a high number of transactions per second and data integrity and data security. So if you check our blockchain core and Aurora integration, this is the architecture of our core network. Here you can see core means there are some different nodes are there, the different machines. They are syncing together to form a network. So, and Aurora is a gateway to link with that core. So you can see that we have different cores are multiple nodes and syncing each other, and we can also scaling up horizontally to make a secure network. And we are using SAP 256 encryption for the security and encryption and about our network consensus protocol, we are using FBA FBA stands for Federated Byzantine Agreement. So as you can see, Federated Byzantine Agreement, which is uh, similar to other blockchain network, Diamante Net employs consensus protocol known as the DCPU, which based on Federated Byzantine Agreement. FBA differs from other well-known concession mechanism like proof of work and proof of stake. Proof of work relies on nodes computational power, and proof of stake relies on node staking power. So by here in federated FBA, that is based on the relying on agreement of trusted nodes. How they are trusted? So in you can see in the document that trusted nodes are grouped together, formed a quorum set, and all the quorum set are uh, going through the different validity checks and acceptance layer and conformance layer. So you can see our different components of our consensus protocol, that is quorum set and quorum slices, node blocking set, states, and quorum and statements. So how they can ensure that is one transaction is valid or not with the different types of protocols like nomination protocol and valid protocol. So each nodes in the quorum set are giving posting vote for the all the transaction, and as per that, so they are checking the validity of the transaction and acceptance of the transaction, and then if all trusted nodes are accepting that transaction, then only confirm, and then only we are publishing into our DCP log. So these are the overall architecture and flow of our network of Diamante Net, and how Diamante Net uh, confirming the transactions and all. So on this transaction and on this network, you can build different tracks. So these are the brief description about different tracks. You can build dApps, different dApps, DeFi track, and different asset related tracks and different wallet related tracks. So in dApps related tracks, you can use our network for social media, staking program, and tracking some that other things like a voting system, and you can also use for voting system. And in DeFi track, you can use for our DEX, decentralized exchange. And for in asset, you can use for NFT and gaming token for reward mechanism, and for any reward and wallet related. So about how you can build these tracks on our network and all these things. So I'll introduce Calvin. He will give more in depth in practical about how you can build this network. Over to you, Calvin.
Thank you, Surya. So, good afternoon, everybody. So, from here, we shall discuss about the ideas that can be built on Diamante Net and how those ideas can be built on Diamante Net. So, coming to first part, how we can start building on Diamante Net. What all things can we have? And what all things can be utilized? So, first, we have a Diamante extension, which is a browser extension, which can be used to interact with apps because user will be having a wallet, and that wallet can be imported in the extension, and it can be used to interact with apps. And coming to second point, we support JavaScript SDK and Golang SDK. So according to the technology stack you have decided for your project, you can use the SDKs accordingly. And coming to the part, Aurora API service. Aurora API service is a API service provided by Diamante Net or any one of the core node, through which we can read the blockchain state or update the blockchain state. For example, it can be used to fetch accounts resource or transaction resource or to submit transaction. So, so we will proceed to next slide. Okay. So we let's take a look into our Aurora API service. So there are several endpoints available in the Aurora API service, but I would like to explain about three of those your service provided by the Aurora. So first is accounts resource. Using accounts route, we can see accounts detail, like what is its balance and what assets being held in that account, and what all operations has been performed by accounts in the past, or transactions that has been done by account in the past. Basically, accounts history. And next comes transaction details. We can get a transaction history on of past transaction happened in the Diamante Net. And for specific transaction, we can see what operation was involved or how many operations were involved in the transaction. And coming to assets, we have assets route, which will list all the assets being created in the network. And along with it, we will also have assets detail, because in Diamante network, each asset is defined by its issuer. So issuer, we can issuer address. We can imagine it as like an identifier which differentiates each asset. Let me share my screen. I would show this services what we have discussed now, so that you guys will have a clarity. Okay, let me know if it is visible.
Yeah, it's visible.
Okay. So this is our route connect, and you can see various routes or services available. You can also see that we have port support. So if you are developing dApps, so if you when you are developing dApps, you might need some disk tokens or account. So you can use this route to fund your accounts from code level. And similarly, you can check what's the current fees and what all effects happen in past assets and so on. So let's go to accounts resource first. So this is it. So through accounts route, we can ask a resource of particular account. So when I hit this URL, we can see give all the details of that account. We can get the account sequence, its ID, and what was its last modified ledger at what time, and what all its threshold values, flags, and balance. You can see balance is array, which will have by default it will have native asset and all the custom assets which this account will be holding. And we can see who all are signers for this account. By default, for account, the account itself is a signer with a weight 1. And this is a data field. Account can use this data field to store any data. So coming into this accounts resource, you might ask what are this threshold? What do they mean? So as I discussed, there are many operations supported by Diamante Net. If you go through our developer docs, you can see the list of operations. All these operations are segregated into each threshold values. For example, if we take payment operation, it falls under medium threshold. Let's take a deep look into this threshold values and sorry, about this threshold values in multi-sig part. So next we can see a transaction history of particular account. By default, it won't give an ascending order. So we have to specify in what order we need. So I'm specifying here ascending order. So it will give me all the recent transactions. And if you want to know about a specific transaction details, we can see here we have this operation route. If I hit this operation route, I can see what exactly happened in the transaction. Let me show you. You can see we have a transaction ID and what is the operation involved. This has been requested to our Aurora client. So we can see this is a transaction hash and the type is payment. And asset used was a custom asset with this issuer, and it has been sent to this user this much quantity. Likewise, we can see for all the transaction details, irrespective of operations used. And same goes here. If we want to directly see the operation list, operations performed by the account, we can directly request operations route for that specific account, so that we will get everything in detail. For example, you can see this account. Let me request it in descending order. You can see, lastly, this account has performed a payment operation, and before that, it has used set options. Similarly, so on, we can see all the operations this account has used in past. So you can see manage data operation as well here. So coming to transactions, if I request transactions, Aurora client will return me set of transactions that occurred in the network. So even here I will ask in descending order, so that I will get recent transactions. So here it will list me all the transactions happened. By default, only last 10 IDs data will be available. If you want more, we can define. Currently, the limit is 200. Up to 200 records can be fetched at a single time, post to which pagination has to be used. If you are developing an application like Explore or anything, you might be ending up setting up an archive node, so that once you set up an archive node, you'll be having the entire blockchain state or data in your DB. Because Aurora client has a DB. I'll just brief about how Aurora is connected to our network. Whenever a node is being set up in our, whenever node joins our network, it can be a full validator or basic validator or even an archive node. So these nodes will be participating in the consensus mechanism, and they'll be relaying messages back and forth, and they'll be always maintaining the network state in their DB. So whenever a node can have a client setup to it, it's optional. A node can have a client setup to it. So let's say we want to set up a client for a particular node. So we'll be setting up our Aurora client. It's written in Go. So we'll be defining to which node it has to connect and few details required. So that this as soon as the Aurora client is put up, it will go connect to a respective node to which it has to connect, and it will start fetching all the data from the core DB to its DB. So whenever you request Aurora client, this data are being served from its own DB, not from the core DB, because Aurora DB will be always in sync with the core DB, getting fetching the data and storing it here. So that's why whenever you request recent transactions from Aurora client, by default at most we can get only 200 data. If you want more, we can. If you want more for your application, you have to set up an archive node and a Aurora client for it, from which whose DB you can easily fetch all the entire data you want. So coming into assets, I think same goes for seeing operations of a specific transaction. I think I have already explained before. Let me also explain once again for specific transaction. If you want to see what operation or what effects has happened, you can ask Aurora client. For example, for this transaction ID, I've asked what effects happened. So we can see the account has been created and another account has been debited because it was a payment operation. Let me show you. Oh, sorry. It was a payment operation. You can see here. This asset has been sent from this account to this account. So we can see in detail what effects happened exactly. You can see from one account it got credited and from another account it got debited. So combining all the services, you can use it in the tabs for your requirements accordingly. So Surya, could you share back your screen?
Yes.
Till now, if you have
Yeah, if you guys have any query, you can ask. You can unmute yourself and you can start asking your queries.
Yes. Okay, looks like we don't have any queries. We can proceed next. We'll have this QA session at the end. So as I discussed, we support two SDKs. One is a JavaScript SDK, another one is a Golang SDK. So I would like to explain about our JavaScript SDK by going through the codes. So in this session, we'll be covering up five operations. So one is a create account, or to, instead of specifying operations, I would like to tell concepts like how create account is happened, creating asset, and storing data on the chain, and what is memo in our in Diamante Net, and how to set up a multi-sig wallet. So I will share my screen, and I will take you guys through our JavaScript SDK and its implementation. Okay, is it visible? Okay. So first, we are defining like a few wallets here. So from its private key, we can set up a wallet in local. So I have created a few wallets here. Okay. And let's see. First, let's go into minting assets. Or let's take a look into creating account. So we create the function. Create account. So when we are creating account, we will be requiring the account which has to be created. So I will name it account, and who is going to be created. For this example, we'll just keep it simple. So first, let me define the process. So first, we have to set up a server connection. So we are connecting to our testnet server. You can see DIAM testnet on time circle is our Aurora client, which I just showed. So here we have we have set up our Aurora client, and next step would be loading or preparing our source account, which is going to initiate the transaction. So in this case, it is going to be the one who is going to initiate the transaction to create account. Because in previous workshops we mentioned, just creating a key pair doesn't mean that that account will have a state in Diamante Net. If you have created a key pair, and if you request that public key in our network, our client will simply throw back telling 404 resource not found. Because in order for account to exist, it should hold a base reserve. So whenever it holds a base reserve, a new state is created. From that point, the state is managed according to its operations or transactions managed. So first we are defining the source account which is going to be created, which is going to create this new account. So I will remove few parts. So here we are building the transaction. We are telling, okay, this is the account which is going to be a source account. And fee, I would like to use the base fee, the Diamante Net, and network passphrase to target which network, or to for validation process when transaction get passed. And this is the main part. So in a single transaction, we can include up to 100 operations. So in this case, I'm including a single operation. One can see. So this operation, if you click on operations, you can see the list of operations here. You can see it. there are many range of operations which can be utilized. So from this available operations I'm going to use create account. Let's see what create account takes. So here's the create account. So create account, that object requires two fields. What is going to be destination account, and with what balance should that account be created in the Diamante Net. By default, this starting balance, which we will be mentioning, should be always equal to or more than base reserve. If it goes below base reserve, our network will simply tell, client will throw back telling that insufficient operation underfunded, or reserve is underfunded. So I'm defining the operation here, and as we saw, you take two fields, destination and starting balance. So starting balance, would like to mention it as one, because in testnet the base result is one. So I mentioned it as one. So the account is the this is the account which we are going to create. So the parameters passed here will be keeper objects. So from that object we can derive the public key and private key. So we have defined which network we are going to use. We have loaded the source account, constructed the transaction, and added one operation, which is create account operation. And here I am setting the time bounds, and I'm calling the build function. Once the transaction is built, then we have to sign the transaction. So in this case, the transaction will be signed by the creator, because he's the one who is building the transaction. So he should be the one who is going to sign and submit it. So here we can see, we can call the sign function, and we can pass the creator's keeper. So the transaction will be signed here. So at this point, we have all the things required. So we can submit the transaction to our network. So we call the submit transaction function available in the network server, and we pass the transaction object. Once this transaction is submitted, we'll be getting a response. Okay, and the response we can check if it was successful or not. Response is an object. It's a nested object, so it'll have many fields with it. So in that case, in that from that we'll be requiring only to check if it is successful or not for this demonstration. So we'll be checking if it is successful. If it is true, then we'll just put a message. Dot created account with balance. Since we have offered one, so we'll mention one. And transaction hash we'll get from this object. If anything goes wrong, we'll can see it in the catch block. So now our function is ready. Now let's set up the wallet. Which wallet we are going to use. So we call create account function. So we can see it requires two parameters. One is the account which has to be created. Another one is the creator. So let me go to laboratory and create a simple keeper. Okay, from laboratory I have generated this keeper. Okay. So this is the account. See, if I copy this account, let me copy this account. You can see, right? It's a keeper generated. Let me call the create account function here. And let's check if this account exists or not. Simply return here to stop the execution. And this account object, if it exists, this account is object which holds all the data which I just showed in my browser. So let's check if this account exists or not. From private key, I will generate generate a prepare object. So here I'm passing this account because that function requires two params. One is account and another one is creator. For example, I will just pass creator as art4. Now we can see this code will go to a catch block telling resource not found. We have got a response telling 404 resource not found, which means the wallet you have sent the requested details doesn't exist in our network. So now we are going to create this particular wallet. So I'm going to create account operation and I'm doing all the temporary changes. So now let's run the code. So from wallet 4, we are going to create this account. So I'm passing the account and the wallet 4 to this function. So I'm running the code now. Okay, I think somewhere will be wrong. Okay, there was some naming confusion. Let me change to underscore account. Since the name variable name was used, call confused. Running it again. Just a minute, let's check what went wrong. So we are passing this account, which is not yet created, and we are using wallet 4 to create this account. So create an account will come here. Let's see what error we got. Transaction failed. Okay, I forgot to check one thing. Let's see if this account wallet 4 has enough dimes or not. Because dimes are base reserve. Sorry, dimes with native asset now network. So wallet 4 dot. What happened here? Okay, we are already initializing it now actually. In wallet we are getting the wallet force publicly. So let me check if this first if this account has enough dime balance or not. Or let me do one thing. I'll just create a brand new wallet. I'll fund it with 100 times from the laboratory. So I will just create a keeper and I will request it some testnet time. Okay. So this will be our new fund account. So create this account which I just created and I funded with 100 testnet times. Oh, just a minute. Okay. I forgot to mention one more thing. See, as I mentioned in the testnet, the base reserve is 1. So I can't exactly create account with exact base reserve. It should be always, it should not be equal to, or it should not be equal to the base reserve. It should be always greater than base reserve. So let me add amount 2 here. That's the reason our transaction was failed. Now if I again call it, so guys, forgot to change one more thing. Actually, that account got created since we had a small typo error at last. So let's, I've generated another simple key pair, and I'm replacing it here. Now I'll also show you the copy key pair. So this is the new key pair we have generated. So I mentioned I'm creating a key pair object from its key here. This account doesn't exist, and this is a create account which we just created and funded with testnet times. I think I have changed everything. Okay, you can see created account. This account which we just generated here has been created with balance 1. Oh, sorry, 1 is hard coded, so you guys are seeing it. Now let's see this transaction hash. Okay, hope my screen is visible. So I have copied the transaction ID and I'm pasting it here. First, we'll see what all effects happened. So you can see from the creator account, that account got debited with of 2 times. We can see asset type is native, which means time. So 2 times has been debited from the source account, and a new signer has been created in the network, which is that new account. New signer has been created with a new state. So you can see here, its weight is initialized to 1 default. So, and here you can see the operations involved of this transaction. It's a create account operation. This is a transaction hash. This create account operation was used with a starting balance of 2. From fund is the operator which we created, which we used, and account is the new keeper which we generated and created before. So regarding create account or about accounts resource, if anybody have any queries, they can ask now before we continue with other operations.
Yeah, you can unmute yourself and you can ask queries or you can drop a message on the chat. Yeah, we can continue, Calvin.
Okay. So is my screen visible? My screen is visible. Okay.
Yes,
So
it's
now we just saw how accounts. What is the process of creating account? Till now, you guys might have went to a laboratory and created a simple pair and funded on spot. Same thing, and I forgot to mention one more thing. During create account for testnet, you can directly integrate or call the friend bot URL which can be found in our Aurora client. I show right available routes. You can see the friend bot URL. Instead of for testnet, you might be requiring creating a fresh wallet. To fund that wallet with testnet tokens, you can call that friend bot URL. Friend bot URL will create and fund that account with 100 times. So we have seen about create account. Let's take a look into creating assets. So you can see we have defined, as I mentioned before, we have defined few wallets here. So first let's consider this wallet as a distributor who is going to distribute assets for other wallet. Let's say it's going to distribute for wallet receiver. Receiver going to receive it. So here you can see I'm calling a synchronous function called setup receiver, to which I'm passing the receiver key pair, distributor key pair, and what is the asset name that's going to be created. Let's name the asset name as token 123. Okay. So here, same process will be followed. We have to define which network we are going to connect by specifying the Aurora client URL, source account, and here we have to create the asset object. Because in previous create account operation, you might have seen automatically the asset will be native asset. So we don't have any fields over there. But here we have to mention asset has to get which asset has to get given trust line. I think I forgot a thing to explain. Sorry, guys. So before a distributor can mint assets to receiver, because by default, if a receiver mints asset directly, it will never be visible in its balance feed due to the network architecture. So the process is a distributor has to mint the account to a receiver. So it will be minted and sent to a receiver, so that it will be shown in the balance. So in our example, distributor will be minting asset asset token 1 to 3 to receiver. So as I said, before receiver can accept or take this token in its account, it has to create a trust line. So that is the reason we are calling this setup receiver function, passing the receiver, distributor, and the asset. So here we can see we are defining the asset here. So as I mentioned before in some time, every asset is identified with its issuer. Issuer is the wallet which issued it. So in this case, you might ask, the asset is not even created, but why we are defining? We are just creating a trust line. Before minting asset, receiver is getting prepared to receive this asset. So we are telling, okay, this is going to be my asset name, and this is the wallet which is going to distribute it or mint it. So here we have defined our asset. Then we are constructing the transaction, and here we are adding a different operation this time called change trust. We are telling, okay, so basically this account is going to make a trust line or trust this account to accept it. Then the transaction will be signed and submitted. So once it's submitted, you can see trust line, what is hash and everything. And immediately after that, after trust line is created, we are ready to mint the asset now. Okay. So I'm calling the asset minter function where I'm passing the asset, distributor, and the receiver. So we can see same process we are doing here, but this time we are using a payment operation. And I'm telling the destination address is going to be here because this, you can see this function, this transaction, the source is distributor. Distributor is the one who is going to make this transaction, and the distributor is mentioning payment operation. Destination will be the receiving address. Sorry, destination will be the receiver address, and what asset. See here at this point, since this asset with this issuer doesn't exist, here the asset will be minted, which will be it will be created in the network with the amount what we specify here. A note has to be taken here. Once this asset has been created, its supply can never be increased, which means it can't new tokens can't be minted. They can only be locked forever. So here I can see, okay, destination going to be a receiver. This is the asset which I'm going to create with a supply of 1,000. So now let's see. Now let's run it. Since setup receiver is a asynchronous function, we have to make sure this process is completed. Then only we can go move to the next process. So we can see the holder. Okay, we can see trust line is created first. Once trust line is created, asset token 1 to 3 is distributed to this account. You might see there will be different public addresses. Here we are defining trust line has been created for token with this issuer. For this token, this issuer is the identity. For example, if someone creates another token, anybody can create a token with the same name, but the issuer will be different. So find the originality of a token, issuer address is used. So this is the process of creating assets in Diamante Net. If you define the supply accordingly, it can be treated as an NFT. For example, in my above implementation, I have given supply as 1,000. If I make this supply as 0.00001, this means it's a collectible, which means there is at most only one supply, because beyond this it can't be fragmented. Now let's move on to, okay, now asset has been minted. Now let's see how this asset can be transferred. So now receiver has got the asset. Now let's transfer it to wallet 4. Before wallet 4 can receive it, wallet 4 has to set up a chain, trust chain with it. So same process continues. This time you can see I'm passing wallet 4 as the source account. So you can see this wallet is going to create trust line for token 123. Okay, trust line has been created. Okay, oh, I think I forgot to save the code. Even transfer function was executed. So you can see. So you can see. Just a minute. I think there was some. Okay. Let's call the transfer function now. In previous step, we have set up the test line. Now we are calling transfer. So where distributor is going to send wallet 4. Sorry, receiver is going to send wallet 4. Let's see the amount. Okay, something happened. We got a bad request. I think our code was not saved when we ran. I think change testing operation was never executed. So now I'm properly executing. That 4 is creating a testing for asset token 123. So you can see program got terminated and test line has been created. Now let's transfer to wallet 4. So we can see asset token 123 has been transferred to GP3, which is our wallet 4. You can see here. So if I go to my Aurora service and request for this account, I can see this asset. I will show all this at the last. So now transfer is done. So let me tell you about what is memo. So in transfer, I have showed we are using payment operation, which can be used to send and receive assets on Diamante Net. So when you're making transfers or any payments, you can there is a feature called memo, to which you can add some memo about other transaction. So for example, you guys can see I'm calling this function transfer memo, which is exactly same as the previous function. Apart from this line, where I'm adding memo, telling my memo is going to be of text type, and this is my text. By default, we have a restriction here. Memo can't exceed 20 bytes. So you can mention only small memos here, which is less than 20 bytes. So here I can see. So here I mentioned sample memo, and running code. Okay. So this transaction hash will just paste it here. So at the end, once we complete all the operations, we will go to our cargo and look into it. So when after this coding example, we'll get back to Aurora client and we'll check this transaction hash if it has the memo included or not. Let's see about storing data. So let's say wallet 4 wants to store data with the key as car and value as SUV. So transaction building will be same, but operation will be different. So here we are using managed data operation, where I am mentioning, because managed data field of account is like a key pair value. There should be a key for which corresponding value will be there. So operation I'm mentioning, my key name is going to be the key which is getting passed, and the corresponding value will be the data. So I'm running. Okay, so transaction has been completed. So at the end, we'll go and see this valid force account, and we'll see what if this data is present or not. So coming to last part, setting up multi-signature wallet. So in between, when I was explaining about our Aurora client, about our accounts, accounts model, I have shown you few threshold values, medium, high, and low threshold, and I have told this all operations mentioned here. They are segregated into various threshold values. For example, as I mentioned, you can take payment. Payment is operation which falls under medium threshold. Okay. So let's set up the transaction, and I'm using this operation now. To create there is operation called set options, which can be used to define the home domain of a account, or add a signers to its list, or update its threshold value. So you all can see I'm calling set options operation here, and I'm updating my medium threshold to 2. By default it was 0. By the time when I was showing the Aurora client, you guys might have noticed 1 because I was previously working on it. Now again I'm updating it to 2, and I'm adding a new signer. Okay, telling okay this is going to be a new signer. His weight will be 1, which means whenever this particular account whenever this particular account makes a payment operation, the transaction would require a weight of 2, which means the signature should be equal to 2. So in that case, let's see. In that case, let me first set up the multisig. In practical demonstration will be we are setting multi-sign right here. For this demonstration, I am adding only one signers, but in reality, we can add a number of signers with any range of weights. So we can see a transaction. Now let's do one thing. I'm transferring for valid. See, valid 2 has created a multisig. It has added a multisig. Now let's try transferring one native time from valid 2 to valid 4. Okay, you can see let's uncomment this valid. You can see valid 1 is the source, and it's a payment operation. Destination is going to be valid 2, and this is how we mention native asset. And amount should always be mentioned in string. So I'm just signing it. You can see here, I'm just signing with valid 1, and I'm submitting it. So everything might look good, but when we pass this transaction to the network, the transaction will be failed. So let's wait, see. We are getting bad request. The transaction which has been passed has been repeated back, telling it's a bad request. Reason I have, I have mentioned valid valid W1's payment operation which falls under median threshold requires to wait. So by default, this account has weight of 1 by default. WN. I saw we can if you go to our accounts route, we can see in bottom signers list, which will have a public key and this weight. By default, this account itself will have only weight of 1. So when this transaction containing median threshold was signed only with one signer which had only one weight, the transaction was not satisfied. So network routed back. Now let's define the valid which has the authorization or which is added in the sign-in list. In the previous example, we have added valid 3 as a authorized person who can authorize this transaction by adding it to the signers list. So we can see after the valid 1 has signed, valid 3 is also signing up. So what will happen? Our median threshold for this account is 4, sorry, 2. So when W1 which has 1 weight and valid 3 which has one weight means on that account. So you can see when 1 plus 1 will be 2. So now when this account has weight of 2, this transaction will be submitted. You might have a question, what if I assign this transaction in some other wallet so that I can increase the weight? If we are using some other wallet which was never been added to the sign list, the transaction will simply fail. So in the code, okay. So you can see the asset has been transferred, the transaction has been generated. So I will stop here. I think I have mentioned major operations. I'll also push all this demonstration code to our GitHub where you guys can go and refer it anytime. So I would like to tell Surya to take the session.
Thank you, Kelvin, for nice session with detailed practical workshop. So you have said all the things about our Diamante Net operations and different functionalities. Okay, so today we have completed this session. Next session, in the coming session, we'll also tell about our different other operation like offers and sales related offers, buy related offers. So now Sarang, you can continue
Yeah.
for any QSL
So
queries is there or not.
exactly. So guys, if you have any queries, you can unmute yourself and you can ask the questions. Anyways, we will be sharing you the recording of this session, and so this is the time if you have any direct queries, and you can go to our site www.diamcircle.com, and in the footer you will be finding our developer documents, our social handles as well. So Discord we have Telegram, so you can reach out and post your queries. So I think we can wind up the session. So thanks for your time. Thanks, Calvin. Thanks, Surya, for taking this wonderful session.
Thank you all.
Thank you all. Stay tuned for